Welcome to Unacademy, and we are in crash course of circuit theory, lecture 9. Today we'll be discussing Thevenin's theorem and Norton's theorem. Before that, let me tell you about myself. I am sravan Kumar, having 7 plus years of teaching experience and mentored more than 5K students for GATE and engineering services and cracked GATE. Also, let me tell you about the Unacademy learning app installation procedure. Type Unacademy learning app in Play Store and click on this install. If you're opting for GATE and engineering services, you can click on this and you can click on this plus and click get subscription. You can either go for plus or iconic. You'll have a dedicated mentor for your preparation for the iconic. You can also use my code as YSK10 to get the maximum discount and click on this proceed to pay. You'll have the payment platforms as debit, EMI, UPI, wallets, net banking. Using any of these platforms, you can make your payments. Let me tell you about the Unacademy Combat. Unacademy Combat is the India's largest fortnightly competition for GATE. The best questions by the best Unacademy educators. So the challenging questions are curated by the best educators of Unacademy, and the questions guaranteed to keep the test engaging, challenging, and fun as well. So it's a super fast and fun with real-time ranking, and see how you rank against others with a live leaderboard after each and every question. So compete with the best, know where you stand among all other contestants. So you'll have a detailed video solutions by the top educators. Get in-depth video solutions for the questions right after the contest. Compete, crack, and conquer. You'll have the scores, leaderboard, rating, and awards as well. So compete with the best and win amazing prizes like Apple MacBook as the first prize and Apple iPad as the second and Apple AirPods third for the third and rupees 1000 Amazon vouchers for all the top 100 rankers. So the Unacademy Combat is India's largest fortnightly competition for GATE. Challenging GATE questions created by the best educators, super fast and fun with real-time ranking, compete with the best, detailed video solutions by the top educators. So enroll for free. It starts on December 16th. The registrations are open. Register now. So coming to circuit theory, today's topics are Thevenin's and Norton's theorem in circuit theory. We'll discuss Thevenin's theorem and Norton's theorem for today. So let me start. So theorems are basically useful when you have more number of nodes and meshes. You'll be easily able to find the response in any element when you know. Amen Kumar, waiting. Thank you. Good evening, Soumya. Good evening, Manasa. Good evening, Navina. Chandrakiran, good evening. And Shivkumar, good evening. So the response in any element can be easily found using these theorems. So you have many theorems. To name a few that I'll be discussing in the next upcoming classes. And in this class, one is Thevenin's theorem. The other one is Norton's theorem. We have a reciprocity theorem, also superposition theorem, and maximum power transfer theorem. Also you have Elegance theorem, Millman's theorem. We'll discuss a few in this course. We cannot discuss all these theorems. You also have something called compensation theorem. So these are some of the theorems. So in this, today I'll be discussing Thevenin's and Norton's theorem. So before getting into that, let me tell you once again the video quality. The screen that you are looking in your mobiles, you will have three dots at the right top corner. If you observe, if you are using your mobile, click on this. You'll have a small pop-up here, which has, if you click on this dots, you'll have pop-up, and in that you'll find report quality, captions, play speed, and so on. In this, click on this quality. There is other pop-up that will come here. When you click on it, you'll have 144p, 240p, 360p, and 480p. Please click on this 480p for better video quality. Please do this. Some students were asking me about the quality, video quality. Nagesh, good evening. Welcome to Circuit Theory Crash Course, and we are discussing theorems today. Thevenin's and Norton's theorems. So let us start with Thevenin's theorem. Thevenin's theorem. What does it state? Thevenin's theorem states that any linear bilateral network can be replaced by Vijay, good evening. A single voltage source in series with a single resistance. That means, let us say you have a network which is connected to some, let's say, load. This is the load and this is some linear bilateral network. This you can replace it by a single voltage source in series with a single resistance. This is that network. Any network which has some active and passive elements can be replaced by a single voltage source in series with a single resistance which is connected to a load again. And this value of single voltage source is called as VTH or VOC. It is called as open circuit voltage or Thevenin's voltage. This is VTH. And this resistance is RTH. So the resistance is Thevenin's resistance. and these are found at the load terminals A and B. Let us denote them as Srinivas. Good evening. So this is for DC, this is the equivalent circuit. If you want the same for an AC, the same thing can be replaced by a voltage source in series with an equivalent impedance ZTH. Similarly, you can take the AC equivalent like this, which is also connected to some load. So these values are, this is VTH gain plus minus, and this is ZTH, and this is the load. And what is this load is any element where you have to find the voltage or the current. Now let us say so this is the voltage and the resistance, and this value is RTH, this is VTH plus minus, this is also called as VOC or VTH. So these are voltage and resistances which are connected to some load. Which are connected to some load. Here, if you are asked to find, let us say current, load current, what is load current is equal to, if you apply KVL to this, if this is connected, if you apply KVL to this is nothing but load current. If you apply KVL to this loop, it is VTH is equal to RTH into I plus RL into IL. So what is IL from this? IL is equal to VTH by RTH plus RL. So this is VTH by RTH plus RL. RL will be a known value and you have to find this VTH and RTH always if you are asked to find load current. So let us see what is the procedure to find voltage across resistor, VTH and RTH by considering a circuit. Let us say you have a circuit like this. Let's say this is your circuit. I'm taking this circuit here to the right. So let us say this is your circuit. You have a resistance, you have another resistance. There is a resistance here again, and there is a resistance here. Let us name them as V1 voltage, R1 resistance, R2 resistance, R3 resistance, RL resistance. Let us say you are asked to find, the question is find current in RL using Thevenin's theorem. These are important questions as far as your semester exams is concerned. Vijay Dhawan, please mention the sign as well. Definitely, definitely. Yeah, plus minus. So using Thevenin's theorem. So now let us consider how do you find this. So the equivalent circuit to this Thevenin's equivalent circuit, in the first solution you need to draw what is Thevenin's equivalent circuit. First we'll draw what is Thevenin's equivalent circuit in this. So Thevenin's equivalent circuit is a voltage source in series with a resistance, which is, here we are asked to find current in load. So this is the load resistance RL, and this is RTH. This would be VTH plus minus. Right. So in this, if you are taking this here plus and minus, and this as plus and minus because the current is flowing in this direction, this is the load current. So what is load current? IL is equal to, just now we have seen, VTH by RTH plus RL amperes. RTH plus RL amperes. Now you need to find VTH and RTH using this circuit. Find VTH and RTH. There is a procedure to find VTH and RTH from above circuit. This is the question. Anup Sagar, good evening. No problem. Even if you are late, you have joined the session. Very good. Anup Sagar. So I'll take this circuit to the next slide and tell you how do we find VTH and RTH. If you know VTH value, RTH value, and RL will always be given in the circuit. If you are considering here RL, so you can find IL very easily. Now let's take this to the next. So this is the circuit. Now let us see how do we find voltage across voltage VTH and resistance RTH. Now procedure, I'll tell you the procedure. Procedure to find VTH. How do you find VTH? VTH is, thank you Anup Sagar, very good. How do you find VTH? First, the first thing that you have to do is remove load resistance in case of a DC circuit. Now second, if you can mark the terminals, mark the load terminals, let us say A and B. This is not mandatory, but because I'll be doing that, I am telling you that. And find voltage across load terminals. Find voltage across load terminals. Then that voltage, the above voltage is VOC or VTH. That's it. This is the procedure to find VTH. I'll also write the equations in the next slide. But for now, let me tell you how to find procedure to find RTH. When I'm saying RTH, I'm only considering only independent sources, not the dependent sources. If they are constant sources, this procedure you can follow. Yeah, open circuit voltage or Thevenin's voltage. Vijay Dhawan, that's correct. Now procedure to find RTH. Same, remove load resistance RL. Second, make all constant independent sources. Make sources is equal to 0, or in other words you can say, replace by their internal impedance. For example, if there is a voltage source, replace it by its internal resistance value 0, ideal internal resistance value. And if you have a current source, replace its resistance value. That means if you have a voltage source, replace it by a short circuit, and if you have a current source, replace it by an open circuit. Then what you have to do is, if this is only in case of an independent sources, if you have the dependent sources, you will have the other procedure which I'll tell you. There are two things. One is, only if you have only dependent sources, there is a procedure. If you have both dependent and independent sources, you'll have another method. So let us now stick to only independent sources. So after this, calculate equivalent resistance across load. So this is the procedure, and let me take this circuit to the next slide and tell you how do we find that. We'll also take up one example problem, don't worry about it. Now this is the circuit. Now how do you find VTH? Is first, as I told you, remove this load resistance. As I told you, remove this load resistance. So you will draw a circuit like this. Yeah, remove this load resistance, and you can mark these terminals, load terminals, as AB. There is a load resistance here. This is R1, R2 and R3. This is voltage V1. Now this voltage, if you find, is called as the open circuit voltage. And how do you find that? This loop is closed loop and this is an open, so the current that is flowing will only flow through this loop. So you can write V1 is equal to, let us take this current as I R1 into I plus R3 into I. From this expression you can find I value as V1 by R1 plus R3. Now what is VOC, or Thevenin's voltage or open circuit voltage? It is equal to, Thevenin's voltage is the voltage across these two terminals, but because the current in this R2 is 0, the drop across R2 will be 0. Therefore, VOC is the voltage drop across R3. That is current in R3 into R3 resistance. What is the current that is flowing in this loop? I. So I is the value you have to write. I is V1 by R1 plus R3 into R3. So this is how you will determine the open circuit voltage or Thevenin's. Yeah, R2 is useless. Very good. That's correct. Because there is no current in that. So VTH or VOC is equal to I into R3. That is V1 by R1 plus R3 into R3. This is how you will determine VTH or VOC. Now let us see how do you determine, we determine RTH. Let us take this circuit to the next slide. Yeah, this is the circuit. Now let me tell you how do we find RTH. So to find RTH, Thevenin's resistance, what we have to do, we have to remove the load and make the sources 0. This source is an independent source. If you replace it by its internal resistance, it is a short circuit. Simply remember that independent voltage source must be replaced by a short circuit. Independent current source must be replaced by an open circuit. So you will short this and you have a resistor here. You have one more resistor here and this is another resistor. You need to find between A and B terminals, that is RAB or RTH. Now if you observe this, this is R1, R2 and R3. Now if you are looking at this circuit from these terminals, what is RTH is equal to, RTH or RAB is equal to R1 in parallel with R3. If you observe, these two are in parallel, plus R2 is in series. Therefore RTH is equal to R1 R3 by R1 plus R3 plus R2. This is how you will determine the Thevenin's resistance. Thevenin's resistance. Now let us consider one problem on Thevenin's theorem and try to solve that circuit. Now the question given here is, I am taking one example from one of the textbooks of Ravish R. Singh. The question is, find the current through 2 ohm resistor using Thevenin's theorem. See, if it is not given as Thevenin's theorem, you can apply KVL, KCL, mesh and nodal analysis as well. That doesn't matter. But because it is given as Thevenin's theorem, we are using Thevenin's theorem to the given circuit. And the given circuit is like this. There is a voltage source of 40 volts, a resistor, again a voltage source. There is another resistor and a resistor here and a 10 volt voltage source. I'll write all the values. So this is plus and minus, this is minus and plus. This value is 40 volts, sign convention is given here. So 5 ohms, units are written. So 20 volts, sign convention given. 10 ohms, only once we take the current directions, we can mark the sign convention of the resistors. Hope you know that. So this is 10 volts. So now if this is given, and what is that question that is asked? We are asked to find current through this resistance. Now this resistor using Thevenin's theorem, do remember using Thevenin's theorem. So this resistor will become our load resistance. This resistor will become our load resistance now. Now, so what we'll do is, as in solution in your examinations, first you need to draw the, as a first step, draw Thevenin's equivalent circuit. First, you need to draw Thevenin's equivalent circuit. So draw that Thevenin's equivalent circuit. What is Thevenin's equivalent circuit? You will have a voltage source of value VTH with plus and minus. Here we'll take it as plus and minus. This is RTH. Current direction is taken like this. We are asked to find current. So this current, let us consider this current. So this is 2 ohms. Let us call this as load current. Now what is load current? IL is equal to, we know already, VTH by, simply by applying KVL. VTH by RTH plus RL. What is the value of RL? It is 2. So this is the load current. Good evening, Koteshwar. So this is the load current. In this load current, you know the value of 2 load resistance. You need to find the value of voltage VTH and resistance RTH using this circuit. Now let us take this circuit to the next slide and let me tell you how do we find VTH and RTH. Now let me take this circuit like this. Yeah. Now what is that? This circuit, I'll redraw it to find. I'm gonna find what I'm gonna find. Now I'm going to find in this to find VTH. Thevenin's voltage I'm going to find. So to find Thevenin's, you need to remove this load first and mark these terminals as A and B and find the voltage across that. So I'll do that. So this is 40 volts, a resistance, a voltage source again. You have this voltage source, this will be present, and you have a voltage source here as well, and this is an open circuit. Now this is A, B, and this is VTH, voltage across these two terminals. I'm sorry. So this is plus minus 40 volts, 20 volts, 5 ohms, 10 ohms, 10 volts. So in this, from this you need to find VTH. So to find VTH, first I'll write what is VTH. What is VTH is equal to, I'll just take that loop separately. This is the resistor, this is the voltage, and this is the VTH. Now let us write what is VTH. So let's call this as plus and this as minus, this as minus and this as plus. If you consider a current in this direction, let us say, now this is the current direction. So this is VTH is equal to, you can write VTH is equal to, so in this 10 you'll have some current. So let us consider that current as, let me consider a loop current in this. Let us consider that current as I1. So this current is I1 here, and you don't have any current in this. This is 0 because here it is an open circuit. But because of this current I1, there is some drop in this, and that is 10 into I1. So you can write VTH is equal to 10 into I1. So this is plus minus, you are moving in this direction. So this is also plus and minus, and the value is 10 volts. So plus 10. So this is VTH. In this, so I have, let me tell you once again. This is the loop. This is the loop. Anil, good evening, Anil. So this is the loop. In this loop, I'm taking it loop separately, and I've considered this loop, and I'm writing VTH. VTH is equal to 10 into some current, and there must be two currents, but because this is an open circuit, generally in an open circuit the loop current is 0, and because this loop current is 0, the drop across 10 is 10 into I1. So I have written 10 into I1, plus you have a voltage source which is opposite to this VTH, that is, this is plus minus to plus and this is plus to minus, so it is 10. Apply just KVL in this. So VTH is 10 into I1 plus 10. So that's the value of VTH. But do you know the value of I1? No. So you need to apply KVL in this first loop. So apply KVL in loop 1. Let us call this as loop 1. Now if you take this, this is 40. I'll write 40 is equal to, because I'll take minus to plus, so it is 40 is equal to, so this is plus minus, that is 5 into I1. So this is also plus minus, so it is plus 20. So I've discussed about this plus minus and all, how I am writing in the previous sessions. You can check there also. So you can also write plus minus here. So this is minus plus 40, so it is, I'm considering voltage rise. This is all, this has voltage drop, this also has voltage drop, and this as this voltage drop, in the sense this acting like a sink, I'm assuming it. So this is 10 into I1. From this you can write I1 is equal to, I1 is equal to 15, I1 is equal to 20, right? So I1 is equal to 20 by 15. You'll get 20 by 15 amperes. So what is VTH? You can simply find VTH is equal to 10 into I1, that is 20 by 15 plus 10. So you can take this as 2 5 2s are 5 3s are. So 40 by 3, VTH is equal to 40 by 3 plus 10, that is 70 by 3 volts is VTH. So this is the value of VTH, right? You can also just simplify, but you can just leave it here also. So 70 by 3 is the VTH value from this. Let me explain you once again what we have done. We have taken this loop, this circuit, and we have removed this load and marked the load terminals, and marked the load terminals in here, and then we have written what is the value of VTH from this loop. Because there is, this loop is open, the current here will be 0, but because the resistor is common to two loops, there will be a drop because of the current flowing in these loops. There are sources in this loop, so that current must be considered. So I have written VTH is equal to 10 into I1, only I1, not this current, because I have considered I2 or some other current that is in this loop as 0, because this is an open circuit. So 10 I1 plus this voltage source, and then I have considered, because I do not know the value of I1, I need to find it from the first loop. So I have written KVL in the first loop and found the value of I1 and substituted it back in VTH. That's how I got the value of VTH. No, it's not enough only if we have VTH, we also need to have RTH. So let me take this same circuit to the next slide. I'll take this circuit to the next slide, and I will tell you how do we find RTH. So let us take this circuit once again and write to find. In this slide we have found VTH. So VTH ultimately is equal to 70 by 3 volts. Now in this slide we are finding RTH. So let me also take this now. See, how do you find RTH? The procedure is remove the load and mark the terminals A and B and make the sources is equal to 0. If there is, I have just told you, if there is an independent voltage source, just make it a short circuit, and if there is an independent current source, make it an open circuit. So if you observe, there are three independent voltage sources, so we have to just short circuit this. If you short circuit, you'll get this resistor, this one more resistor, and this is an open, and this is again a short. Now if you observe this A and B terminals, the voltage or the resistance here is RTH. This resistor value is 5 ohms. This resistor value is 10 ohms. Now if you observe RTH, finding AB here or finding AB here, both are same, and these two seems to be, if you observe RAB or RTH, these two, if you observe these two are connected here, and the other two terminals are also connected here. That means these, the current is different. So you can say these two are parallel, 5 in parallel with 10, that is 5 into 10 by 5 plus 10, that is 50 by 15 ohms. So this is the value of RTH, that is, you have got RTH value, therefore RTH is equal to 50 by 15 ohms. Now let us take the equivalent circuit. This is the equivalent circuit, right? So this is the equivalent circuit and this is the current. Let us write that. So you have a Thevenin's equivalent circuit like this, which is connected to some load resistance, and the load resistance value is 2 ohms here. We are taking load current. This is RTH. and this is VTH. So VTH we have got it as VTH is equal to 70 by 3, or it is 23.33 volts, and RTH is equal to, we have got just now, RTH is equal to 50 by 15, 50 by 15 ohms, or it is 50 by 15 is 3.33 ohms. So this is, what is the value of this? This is 3.33 ohms. This value is 23.33 volts. Now consider this current. I'm taking this sign convention also. Consider this current, which is load current. Now what is load current is equal to VTH by RTH plus RL. So what is VTH? 23.33 by RTH 3.33 plus RL 2. Now if you just simplify this, you'll get IL is equal to 4.38 amperes. So IL is equal to 4.38 amperes. This is the load current. Hope you were able to understand this. Anup Sagar, Anil, Vijay Dhawan, Karthik, Srinivas, Nagesh, Chandrakiran, Shivakumar, Manasa, Soumya, MN. Hope all of you have understood this Thevenin's theorem and a numerical based on this Thevenin's theorem. Now let me also take one more example and tell you very fastly. I'll take one more example and quickly we'll solve this problem, because it's easy, but there is some confusion students have during solving this question. The question is, find the current through 20 ohm resistor using Thevenin's theorem in given circuit. The question is, the circuit is given something like this. There is a current source. I'll just write directly what we'll do. And there is a resistor. There is one more resistor. You have a parallel resistor again. There is a voltage source. So the values are given something like this. This is 5 amperes, 10 ohms, 5 ohms, and 20 ohms, and this is 100 volts. So this is the question given to us. So from this you can say, the first thing that you need to do, what is that? Draw the Thevenin's equivalent circuit. So what is the Thevenin's equivalent circuit? You have a voltage source in series with a resistance connected to a load resistance. What is the value of the load resistance here? 20. So this 20. So this is 20 ohms is our RL value. Let us consider load current. This is RTH. This is VTH. So what is IL is equal to? We are asked to find current. So IL is equal to, you can write by applying KVL, RTH plus RL. That is VTH by RTH plus, what is the value of RL? 20 ohms. So this is current. This would be first step. I'll write all the steps first, then we'll solve. So we need to find VTH and RTH. So the second step is find VTH, and there is a procedure. Third step is find RTH, and fourth step is finally find IL by substituting VTH and RTH. So this is what we'll do in 4 steps. You'll solve this problem. So I'll take this question to the next slide. So we know already RL. We do not know what is RTH and VTH. We'll try to solve this question. We'll try to find what are we trying to find now? We are trying to find what is RTH, VTH and RTH. So in this slide, I'll find first VTH or RTH, anything that you feel better. So first what I'll do is I'll find VTH. So simply, what is VTH? So to find VTH, here this slide is to find VTH, Thevenin's voltage. How do you find Thevenin's voltage? Remove the load resistance. So you need to remove this load resistance. You can remove this load resistance. So remove this load resistance and mark these terminals as A and B. I'll just redraw it for your convenience. Let us take this as current and this as the resistance given. Here you have one more resistance with terminals A and B, and there is a voltage source. And let's write all the values. 5 amperes, and this is 5 ohms, this is 10 ohms, and this is 100 volts. So if you observe this as A and B voltage, this voltage is VOC or VTH. Directly you can say that instead of finding and everything, directly you can say that the voltage here across A and B is 100 volts. Therefore, what is VTH is equal to VOC is equal to, or VAB is equal to 100 volts. So this is Thevenin's voltage simply. Now let's take this circuit to the next slide and find what do you need to find? We need to find RTH. So let's take this here and let us find here to find RTH. What we'll do to find RTH? Same, remove this load and make, if there is a current source, make it open circuit, right? You need to open this. If there is a voltage source, you need to short circuit. So let me redraw for your convenience. So this is open, you need not even represent also. This is the resistance, this is the another resistance, this is open again because we are removing the load and marking the terminals, and this is a short again. Now if you see, this is A and B, this is 5 ohms and 10 ohms. Let me redraw it once again. So this is 5, you need not draw this simply, and this is RTH. So this resistance, and there is a short circuit across this A and B. Now what does this implies? This implies the Thevenin's resistance is 0 ohms because there is a short circuit here. That means you can also make this short circuit across these two terminals. That means these two are short. This is 5 ohms, this is 10 ohms. If you observe, this is a short. Students get confused in this because if this short circuit wasn't there, if here the current source and voltage source were interchanged, this would have been an open and this would have been short, and only 5 ohm resistor gets short. What I told you now, if this is a voltage source and this is a current source, this would have been short and only 5 ohm resistors get short, and you would have got VAB is equal to 10. But because a voltage source is to this side and AB is shorted, so you need to short both 10 ohm and 15 ohms. Therefore 5 and 10 ohm becomes dummy resistors there. So the resistance, equivalent resistance in this case is Chaitanya Reddy. Hi sir. Hi Chaitanya. Mahesh Reddy, good evening. Welcome to Circuit Theory Crash Course. So RTH is equal to 0 ohms. So we have got VTH is equal to 100 volts. RTH is equal to 0. What is RTH is equal to 0? Resistance 0, short circuit simply. So let us draw the equivalent circuit now. So the equivalent circuit is, this is the load resistance. What was the load resistance for us? The load resistance was 20 ohms and VTH value is 100 volts and RTH value is 0 ohms. So this VTH is 100 volts, RTH is equal to 0 ohms, this is 20 ohms. Now let us redraw this once again. This is VTH, RTH 0 is nothing but a short circuit directly and a resistor, and this is load current. This is 20 ohms, and what is this value? Let us take this plus minus. So this is 100 volts. What is this value? This is VTH. What is this value? This is VTH, which is 100 volts. Now therefore, what is IL is equal to? Simply apply KVL in this. This is nothing but IL. It is VTH by, we already know RTH plus RL, but VTH by, what is RTH value? 0 plus RL will give you VTH by RL. Therefore, IL is equal to VTH by RL. What is VTH? 100 by RL will give you 5 amperes. G. Balraj, good evening. Welcome to Circuit Theory Crash Course. So the current is 5 amperes. This is one of the important questions that's being frequently asked in your semester examinations. Find the current in 20 ohm resistor using Thevenin's theorem in the given circuit. You'll just get confused here. One is the open circuit voltage is directly the 100 volts. Even if you try to find it, you'll get the same, or directly you can by inspection you can tell that. And the other confusing point for you is because this is shorted, most of the students write it is 10 plus 5 is 15 ohms as RTH, which is absolutely wrong, which is 0 ohms. That is correct. So, and you will get the load current as 5 amperes. Now this is all about Thevenin's theorem. So now I'll tell you about Norton's theorem. Let's discuss about quickly फटाफट से Norton's theorem कर लेंगे. So that is, let us discuss Norton's theorem. So what does Norton's theorem state is that any linear bilateral or bidirectional network can be replaced by, which has any number of voltage sources, active and passive elements, simply replaced by a current source of value IN or ISC and a resistance and an equivalent resistance and an equivalent resistance of Rn, or that is same as RTH. That means if you have, let us say you have a circuit which is connected to some load, this can be replaced by, this is a network, linear bilateral network, this can be replaced by simply a current source, this is load resistance, in parallel with a resistance of value Rn, and this is IN, which is connected again to a load. Right? So you can replace any linear bilateral network by using a current source in parallel with a resistance. Whereas previously we have seen we can replace it by a voltage source in series with a resistance. Now we are replacing it by a current source in parallel with a resistance. And so Thevenin's and Norton's theorems are generally nothing but the source transformation. Now let us look at this. How do we do this? Now let us consider one circuit. I'll tell you what are these I and IS also. So this is, you have a current source, a current source in parallel with a resistance connected to some load. So this is a current source IN or ISC. This is RN or RTH, both are same. The procedure remains same. So this IN is called as Norton's current, or this is also called as short circuit current, and Rn is equivalent Norton's resistance or Thevenin's resistance across load terminals. Right? Now let me consider one circuit and quickly tell you how do we do that, and also we'll take up with one examples and find. Let me take up with one more example, one example. Yeah, let us consider one circuit. The circuit is something like this. This is the circuit, the same circuit that I have taken previously as an example, the same thing I am taking this. Now let us take this as load resistance, this as R1, this is R2 circuit, this is R3, and this is voltage V1. Now you can replace this by a single current source in parallel with the resistance which is connected to the load resistance, and the load resistance is RL in this case, and this value is IN and this is RN. Now you are asked to find, let us say you are asked to find current in load resistance. Now what is the current in load resistance? Just apply current division rule, which I have told you in the previous sessions. Current division rule is current in any parallel, because if you observe this, this is Norton's equivalent circuit. So current in any parallel, these two are parallel with a current source. Current in any parallel branch is equal to total current into the opposite branch resistance by the total resistance Rn plus RL. And RL is already given in the question. This is the question and this is the equivalent circuit. So this is the question. So because you know this question, RL value is known, you do not know IN and RN, so you have a procedure. So to find, so the first step would be this one. When you're solving in your examination, the first step would be this: drawing the Norton's equivalent circuit and writing IN. Then you need to find IN, and then you need to find RN or RTH value, IN or ISC. Now how do you find this IN and ISC? Let me tell you. And RN RTH is same as the Thevenin's. Now let me tell you how do you find this IN or ISC. Let us consider the same circuit. This was the circuit, and here you have a resistance, load resistance. We have considered this as R1, this as R2, and this as R3. Now what is the procedure to find? Procedure to find IN. The first step is remove load resistance. Second, short circuit load terminals. This is what generally I'll follow. You may also follow some other method. So I have removed this load resistance now. This is the load resistance and short circuit it. And third step is find current in short circuit path. That means finding this current IN. That current is IN simply. So how do you get this IN? Just apply V1. This is I1. Let us take this as I2. Simply apply KVL to both loops. That is very simplest method. You'll get I1 value and I2 value. What is I2? I2 is nothing but the IN value, which is what the required current. And how do you find RTH? We know RTH. How do you find RTH? The same simple way. Let me tell you once again. This is RL. This is R1, R2, R3 and V1. How do you find RL? Simply the first step is remove load. Second, make voltage source equal to 0 or replace them by their internal impedances. That is, if you have a voltage source, short circuit independent. If you have a current source, open circuit that. Then find equivalent resistance. So that means you just have to remove this resistance and make this voltage source as 0. So you won't have this voltage value. So what is this value of RTH now? So this becomes RTH, which is equal to R1 in parallel with R3 plus R2. That is same R1 R3 by R1 plus R3 plus R2. So this is how you'll find RTH. So let us take one problem and try to see how do you apply this Norton's theorem to any given question. Let us take one problem. The question is given like this: find current in current through 10 ohm resistor using Norton's theorem. Using Norton's theorem. So and the circuit is given something like this. There is a voltage source You have a resistor with some voltage source again. You also have one more resistor, and this is another resistor. You also have one more resistor here. Now let's consider these values. The value of this voltage source is 20 volts, and this resistance is 5 ohms. This resistance is 8 ohms, and this is 2 ohms. The resistor value here is 12 volts. This is 10 ohms. So we are asked to find this current in this 10 ohm resistor using Norton's theorem. So the solution is, first step is draw Norton's equivalent circuit. So the Norton's equivalent circuit is, you have a current source in parallel with a resistance connected to a load RL, RN, IN. And what is this value of load current? IL. You can also directly find the load current using KVL or KCL equations. But here we are asked to find Norton's theorem using Norton's theorem. So I am applying this Norton's theorem. It is not that you cannot find by using KVL or KCL. So what is IL is equal to total current into opposite branch resistance by the total resistance. So already RL value is 10 ohms because we are asked to find current in this 10 ohm resistor. Now let us take this circuit to the next slide and find what are the values that we need to find. We need to find what is Rn as well as what is In. We need to find what is In value and Rn value. So let us find In and Rn. Let us take this circuit to the next slide and find these values. So first I'll try to find what is the value of In. To find In, this slide is to find In or ISC. How do you find that? First, remove the load. So you have to remove this load and short circuit that. So I'll just redraw it for your convenience. This is the voltage with resistance. You have one more resistance here. You have another resistance here. This is the voltage source. Here you have 10 ohm resistor, right? So you need to short circuit that. So just short circuit that, and this current you need to find, and this current is Norton's current. You have removed the load and short circuited that. So just this is 12 volts plus minus, this resistance is 8 ohms, 2 ohms, 5 ohms plus minus 20 volts. Simply apply KVL in this loop. Let us take this current as I1. Let us take this current as I2, which is I2 is same as IN. So apply KVL to, let us say this is 1, this is 2. So KVL to loop 1. What you will get? 20 is equal to 5 into I1. 20 is equal to 5 into I1 plus 2 into I1 minus I2 plus 2 into I1 minus I2. By now, when I have told you about mesh analysis, super fast explanation, super clarity. Thank you, Karthik. So 20 is equal to 5 into I1 plus 2 into I1 minus I2. So you will get 20 is equal to 5I1 plus 2I1, 7I1 plus, because you have a minus, you'll get minus 2I2. This is one equation. Now apply KVL to loop 2, second loop. If you apply loop 2, it is, so this is current that is flowing. So this will be plus minus, this will be plus minus, this is also plus minus. So it is 12 plus, this is 12 plus 2 into I2 minus I1 plus 8 into I2. So 8 into I2 plus 2 into I2 minus I1 is equal to 0. From this you can write minus 2I1 plus 2I2 plus 8I2, 10I2 plus 12 is equal to 0, or you can write 2I1 minus 10I2 is equal to 12. This is the second equation. Now if you solve this 1 and 2, you can find I2 value. So solve 1 and 2, you will get I1 is equal to and I2 is equal to as this is minus 0.67 amperes and I2 as minus 0.67 amperes. Sorry. So you'll get the values of I1 and I2. You don't need I1, you just need I2. So I2 value is minus 0.67 amperes because what is I2? I2 is nothing but the Norton's current. Therefore, Norton's current is equal to short circuit current is equal to minus 0.67 amperes. So for the same circuit, you need to find what is RTH or RN as well. So let us consider this circuit in the next slide. So this is the circuit and this slide is to find Rn. How do you find Rn here? Rn can be found by just remove this load and make sources equal to 0, voltage source as short and current source as open. Now I'll just redraw it. So this is the resistor, this is the second resistor, this is 5 ohm resistor because this is short. This is 2 ohm resistor. You have one more resistor and just open it. This is the resistance and this is Rn. Here you'll have 8 ohms. Now if you observe, what is Rn is equal to 5 in parallel with 2. 5 and 2 are in parallel and it is in series with 8 when you are looking at this circuit through these terminals. So you'll get Rn is equal to 9.43 ohms. So what is Norton's equivalent circuit? This is IN, this is IN, this is Rn and this is RL. What is RL is equal to 10 ohms and we know IN is equal to, what was IN is equal to minus 0.67. What is RN is equal to 9.43 and if this is IL, load current is equal to total current IN into opposite branch resistance RN by RN plus RL. So load current IL is equal to IN. What is IN? Minus 0.67 into Rn 9.43 by 9.43 plus RL 10. If you simplify this, you will get IL is equal to 0.33 amperes. If you simplify this, you get 0.33 amperes. If this is minus in this direction, you can take this as, you can take it downward and write it as plus 0.67 amperes also. And this is IL is equal to minus 0.03 amperes downward. If you take IL, this is IL is equal to minus 0.33. Right? So this is how you will find IN value or Norton's equivalent. You will apply Norton's equivalent circuit to solve any given circuit. So once again, thank you all. Thank you for joining me today. I'll just tell you what we have done today. We have solved Thevenin's theorem and numericals based on them. Then we have seen Norton's theorem and its equivalent and solved a numerical based on that. So this was all about today's takeaways, Thevenin's and Norton's theorem. That is, Thevenin's theorem is a voltage source in series with a resistance and Norton's theorem is a current source in parallel with a resistance which is connected to some load, This is load current, Thevenin's resistance, this is Norton's current. This is also Norton's resistance or Thevenin's, and VTH is also called as open circuit voltage. IN is also called as ISC. Thank you all once again for joining me today for this session on circuit theory, Thevenin's and Norton's theorem. As I always tell you, we have India's #1 study channels, Creatrix Great, Unacademy GATE ME, Unacademy GATE CE, Unacademy GATE Telugu, Unacademy SSC JE, Unacademy Computer Science, Unacademy Gate Questions, Electrical Junctions, Unacademy Engineering Foundation, Unacademy Pathshala, and Unacademy Semester Exams. Please do like and share this video. Use my referral code as YSK10 to get maximum discount, and subscribe to this channel and click on this bell icon to get notification of my classes. Thank you all. Thank you for joining me today on this beautiful session on Thevenin's and Norton's theorem.